Hello everyone and welcome to this demonstration video of simulation of process equipment using Aspen Hysys. Friends, in this video I am going to simulate the pipe segment in which the water is flowing. Let me introduce myself. I am Dr. Santosh Walke, currently working in Oman, and I am practicing this Aspen Hysys from last 10 years. So let us start the first demonstration video, that is simulation of pipe segment. Now in this case we are seeing in this image there is a pipe which is almost 10 meter of length. The material of the pipe is mild steel. The pipe schedule is to 80 and the nominal diameter you can say 38.1 inch. The inlet conditions you can see from here is temperature is 38 degrees centigrade, pressure is 2 atmosphere, the flow rate is 10 meter cube per hour. So this is a volumetric flow rate, please remember, and the composition there is only one component water, so it is 1. Now the outlet conditions, we are assuming that the temperature is 38 degrees Celsius, same as inlet temperature. We are assuming that there is no increase or decrease in the temperature. So the fluid package we are going to use is NBS steam, and here we are going to find out the effect of the length on the pressure drop. So in this figure we can find out this is the length of the pipe and how this length will affect the pressure loss in the pipe. Inlet pressure is P1 and outlet pressure is P2. So in this experiment we will be able to verify the effect of the length on the pressure drop by this equation, that is delta P by rho is equal to 4FLV square upon 2D, where this F is the fanning friction factor, L is the length which is constant, V is the velocity of the fluid in the pipe, D is the diameter, this is also constant, rho is the density. Since we are assuming the temperature is constant, so there is no temperature, no effect on the density, and delta P, this is the pressure drop due to the skin fraction. So we'll start the simulation by using Aspen Hysys. So this is the basis manager of this Aspen Hysys. Here we have to complete the two step. First step we have to define what are the components involved in our simulation, and in second which fluid package we are going to use. So in our case we are going to use only water. So we'll type here water and we'll click on this add tab. So this water will come in our database. Then second step we have to define the fluid package that we are going to use for our simulation. So here are the different fluid package available with the Aspen Hysys. Now our fluid package is NBS steam. So we'll click on the NBS steam and we'll check whether the color is green. Now the color is green, that means our fluid package is correct. So we have completed here the first two steps, that is we have defined the components and then we have defined the fluid package. Now we'll enter into the simulation environment. So we'll click on the simulation. Now this is the simulation environment. On this left hand side window, this is called as a pellet window. Now there are the two arrows you can find out. One is blue arrow, one is a red arrow. Blue arrow is a material stream arrow and red arrow is a energy stream arrow. So first we'll select the material stream arrow. We'll have to just drag this arrow and we have to place it in the simulation environment. Initially you can see the color is light blue, and since there is no information, so we have to enter the information like see the temperature, pressure, molar flow. This everything is saying as empty, so we have to define this input properties. So very first we can give the stream name. We can say this is pipe in. The temperature we have 38 degrees centigrade, pressure is 2 atmosphere. So here by default unit is kilopascal. We can select the atmosphere unit by this drop time arrow. Then the flow rate is given as a 10 meter cube per hour. So we'll select the 10 meter cube per hour, and then last information we have to define the composition. Since there is only one component, so mole fraction will be 1. Just click enter and then click normalize and press OK. Now the color of this become green, so our information is complete. So material stream is complete. Next step we have to select the pipe segment. So we can select the pipe segment from here, just drag and place it in the simulation environment. Double click on this pipe segment. Now you can change this name. You can type it as a pipe segment. This you can type it any name as per your process. We have to select the inlet stream, that is a material stream which is going to the inside of the pipe, and the outlet stream, we have to define this outlet stream. We can type it as a pipe out and press enter from your keyboard. Then this will require energy, so we'll create the energy stream like Q pipe and we'll press enter. Now we have entered all the input information. We have defined one energy stream, outlet stream also we have created. Now the outlet temperature we have not defined, so click on the worksheet tab, and here the inlet temperature is 38 degree. Same temperature we are going to enter as outlet temperature, assuming that there is no loss of heat. Then we have to define the pipe dimensions, that is what is the length, what is the increment, what is the elevation, what is the diameter. So click on the rating tab and then click on the append segment. Now here we have to enter the length or equivalent length of the pipe. So our pipe have 20 meter of length. We can enter the 20 meter of length. Here the elevation is 0, that means we are assuming our pipe is a straight pipe. If there is a elevation either in the upward direction or downward direction, then we can give the elevations over here. Now next step, the material also here is a by default material is a mild steel. Now we have to define the schedule. Click on the view segment. Now here there is a pipe schedule. There are 4 types of schedule: actual, schedule 40, schedule 80 and schedule 160. We have selected schedule 80. So if you click on the schedule 80, these are the available nominal diameters in the pipe. So we have selected already 38.1. So select on the 38.1 and click on the specify. Now you can see the color is become green, that means our information is complete. Now we'll see what are the results we got it. So click on the design tab and here click on the parameters. You can see the delta P, this is the pressure drop between inlet and outlet, it become 35.18. So the pressure is decreased by 35.18 kilopascal. The energy required for this is 313.2 kilojoules per hour. Then we can analyze these results by clicking on the performance. We can see its graphical representation. Click on the performance, click on the view profile. Now in this you can find out the length is taken in the increment of the 444 meter from 0 to 20 meters. Elevation is 0. Here you can find out how the pressure is changing from 202 kilopascal to 167.466 kilopascal. Temperature we have assumed in the same. There is no increase or decrease in the temperature. There is no vapor fraction. Even the heat transfer is constant. Flow regime is liquid. Liquid hold up is 1. The friction gradient kilopascal per meter is also same. We can say the dp, that is the friction dp, is also same. Static gradient same, and almost the other parameters are same. Even the liquid velocity is same. Now we will see the graphical correlation with respect to the x-axis. There is the length of the pipe from 0 to 20 meter, and y-axis there are the different parameters we can study with respect to the x-axis. So almost elevation is same, temperature is same. You can say the pressure is decreasing, the kilopascal from 202 to 167. This is a decrease with respect to the length you can observe. Then we will see the velocity, the liquid velocity. We can say up to 0 to 4 it is constant, and from 4 it is increasing up to 16, and then it become again constant. So this is the graphical correlations you can find out between the different parameters with respect to the pipe length. Then there is one more aspect, that is a dynamic aspects, that I will cover it in some other videos because it is some advanced level of simulation. Even in the flow assurance we can see if there is a carbon dioxide is involved, so the corrosion taking place due to the CO2, we can analyze with respect to the pipe length and the rate of corrosion. But for that we require some additional data like pH. So if you know the pH of the component we are fitting, that is water, if if it is 6, then otherwise if you don't know, you can calculate by clicking on this, by knowing the bicarbonate and ionic strength. Then the second is also we can study the erosion. So the erosion velocity, which is given by Vmax, is equal to C upon rho raised to 0.5. There are different empirical constants, like these are taken upon the API, then Salman, Venkat, then the C values can be changed. Then the hydrates also you can study with respect to the pipe length that you require. There are different models available. Then depending upon the initial pressure, then slug analysis, especially in the oil and gas industry, this analysis is very important, and wax deposition, this also we can do it. Now these are the different result analysis. We can do it by using Aspen Hysys. Now we'll come to our basic simulation. Click on this auto position. This tab is for auto positioning and making good view. Now it is looking better. Then you can right click and click on the add workbook table. You can select the first material stream, so the result will appear in the form of the table. Now this is the material stream. You can see here also you can analyze the result. Temperature is constant, pressure is decreasing, molar flow is constant, mass flow is constant, liquid volumetric flow rate is constant, and heat flow is constant. The second table we can add. Right click and click on the add workbook table, select the composition. Since there is only one component, we can minimize still. There is a water, so the composition remains same. Third, we can add the energy stream. This is the energy stream. So in this way we have completed our simulation. Especially in this demonstration, this Aspen Hysys program was used to simulate the pipe segment of the given requirement at a certain temperature and pressure of the passing fluid. Result shows that increases in the length and the increment of the pipe, which leads to increase in the pressure drop value due to much decrease in the outlet pressure. So we can say theoretically the outlet pressure of the pipe segment decreases with the pipe length increases because of the frictional force between the particles of the flowing fluid and the wall of the pipe, and also the internal friction force between the fluid particles themselves. Eventually the pressure drop increases when the length of the pipe also increases. Main source of the error in this case can be uses of the wrong fluid package, that is we can call it as an algorithm error. In this, incomplete data insertion, which can also leads to incomplete simulation, which can be minimized by using the proper data preparation before starting the experiment. In conclusion, we can say that Aspen Hysys is one of the simplest and reliable program on simulating and designing the different engineering process. For earlier time, you can see the process engineers were using or utilizing the most of their time for designing the process before being practically employed. But nowadays, using the process simulator like Aspen Hysys, we can simulate any industrial process by selecting the proper package. Now this will save our time. It can also increases the efficiency and accuracy of the process. In conclusion, proper selection of the pipe segment according to the applications and working environment is very important, especially in petroleum and petrochemical industry. This is because the pipe segment have to be designed according to the pressure, temperature, viscosity, even the type of the flow, and even the chemical properties of the transported fluid through the pipe. In petroleum and petrochemical industry, pipe segments are mostly used for transportation of the oil and liquefied natural gas from one point to the another. Hence, designing the pipe is very important to avoid the problems like rupturing of the pipes, even the corrosion and overall leakage problems of the pipe due to the mismatching properties between the pipe and fluid transported. So I hope you like this video, and in next video I will simulate the compressor. So see you soon. Till then, goodbye and happy simulation.